All right, hi all. So I'm going to teach you about horizontal projectile motion, a pretty cool idea that combines forward motion with free fall in a vertical direction. This is not easy stuff. Pay real close attention. The good news is you've learned all this stuff. Now we're applying it to a situation where we have to look at two different directions, combine that information. So we're going to use our VTAD tables, our kinematic equations. We're going to fill out a chart, and I'm going to make a graph here. And then when we're done, you're going to try some on your own. And hopefully you feel super confident, because I know you can do it. You might have to watch this once or more than once, look at it again, but it's really nothing new. So let me give you the situation. We're going to have a cannon. We're going to aim the cannon horizontally off of some cliff. The cliff is about 125 meters tall. And we want to understand where this cannonball is going to be at various times, after 1 second, 2 seconds, 3 seconds, and we're going to plot its position at various points. So we got to calculate where it's going to be before we can plot it. So to do that, we're going to fill out the chart, and to fill out the chart, we're going to use our table below and break things down like we've learned to. You have to be willing to break things down if you're going to be successful here. If you want to take the lazy way out and just think you know it all at once or just guess, then it's not going to make sense. So the key to understanding how to do these problems is that we have two motions at once. Like I said, we have horizontal or forward, and then we have vertical. It's falling. So as soon as that cannonball leaves the cannon, it is falling immediately, and it's accelerating. So vertical should be pretty straightforward for you. It's accelerated. Okay, and that acceleration is negative 9.8 meters per second per second. Horizontally is also pretty straightforward. The motion is constant. In other words, it just moves at a constant speed. So don't put this down, but if I were to look at the cannonball after 1 second, it might be right here. After another second, it'd be here and here. This is assuming there's no gravity, so let me stipulate that. So if there's no gravity, constant speed means it would just go the same distance each time interval. So all we have to do is understand that and then combine that with what it's doing vertically, and then we can fill out the chart. Okay, so we're going to look at this for 5 times. I'm going to break it down for the first second, and then we're going to use the same equations for second 2, 3, 4, and 5. And we want to look at where is it horizontally, that's x, and then where is it vertically, that's y. Okay, now let's be clear. Its initial height is not 120, it should be 125. Okay, my bad. That's a subtle difference, but it's all right. So we're starting at time 0, we're right here. We're at position 0, and we're at a height of 125. So what we want to figure out is how much we fall for each second and how far we go forward for each second. So that's where our VTAD tables come in. Your willingness to break it down will allow you to be successful. And the problems we do hereafter are pretty much the same thing. Okay, so let's go to this column. Since the ball is moving directions at once, we need a column for horizontal. I already mentioned that. And for the vertical, and that's the y. So I'm going to fill out information here. Okay, so this is the hard part, and it's not that hard if you just stop and think about it. So we have initial speed in the horizontal direction and in the vertical direction. So if you go up to the original information, we see that it's launched at a speed of 10 meters per second. And that launch speed, I'll put a V there, is forward. It's horizontal. So that's clearly our horizontal speed. How about vertically? What is it doing the moment it leaves the cannon in the vertical direction? Well, we didn't aim the cannon up. We didn't aim it down. Since we aimed it flat, initially it's not moving vertically. So that's always going to be the case if you launch something horizontal. Even a gun, or even if I'm throwing a baseball pitch and I leave my hand horizontally, initially it's not moving up, not moving down. It'll eventually start moving down, but initially it's 0. Okay, the time in question, we're going to do it for 1 second. Then we'll do it for 2, 3, 4, etc. The acceleration, that's where I talked about at the very beginning. Horizontally, it's constant motion. That's key, so the acceleration, therefore, is 0. And vertically, it's negative 9.8 because it's accelerating downward. Lastly, what's our distance that it's going to be? Well, that's what we're looking for. We're looking for where is it in the x direction and where is it in the y direction. So let's take each one in turn. So I'm looking for range. I call that x, or you could call it d sub x, the distance in the x direction. So what do I know? I know the acceleration 0. I know the time is 1. I know the initial velocity is 10. I've got my 3 pieces of information. So the equation that makes most sense for x is equal to my initial speed times time plus 1/2 AT squared. We see that equation again. Since my A is 0, this whole thing becomes 0. So I have a very simple equation for how far it's going to go after each interval. It's simply how fast I'm going multiplied by time. So for after 1 second, it's 10 times 1, which is 10. After 2 seconds, it's 10 times 2, so that's 20. So let's go ahead and fill out the table there. So this is going to be 10, 20, 30, 40, 50. And that's what I was showing before. If this is 10 meters is 10, I'm going to label down here, 10 meters, 20 meters, 30 meters, 40 meters, 50 meters, right? If there was no gravity, don't mark this now. This is where the cannonball would be after each second. Okay? Now we just have to add to it where it's what's done vertically. So vertically, I'm going to make a little adjustment to what we normally do. So don't write this down just yet. So vertically, what do I know? I'm looking for a distance. I know the acceleration, I know the time, I know the initial speed. It's the same equation. I'm going to call it y. Here's the adjustment I'm going to make. You can write this down. The y that I'm looking for represents the height. So I'm going to start with the initial height and subtract off what happens by falling. So that's the little adjustment. So I'm going to put y, I'm sorry, I don't want to put a 0 there. I'm going to put an initial. Your initial height, because our initial height isn't 0, it's 125. So it's initial height plus v naught t plus 1/2 at squared, right? So since our initial speed in the vertical direction, so let me put a y there. That's important. So I don't use the 10. That's a common mistake because I want all vertical. This is going to be 0. So my height at any time is equal to my initial height plus what I get from the accelerations. That's 1/2 negative 9.8. That negative is super important there, times time squared, which is 1 squared in this case. So our initial height was 125. I'm going to, for argument's sake, I'm going to use negative 10 for g because it just makes the math easier. So negative 10 times 1/2 is 5. 5 times 1 squared is 5. So I've at a height of 120. Okay, so after 1 second, we've only fallen 5 meters, so we're at a height of 120. So what I would do then is I would go over 10 and go down to 120. So this should really be 125 up here. So I'm going to make 120. I know it's a little confusing, but it will get better right about there. Okay, it's not perfect, but the point is it's fallen below this horizon line. Okay, now for 2 seconds, we do the exact same thing. So my initial height is 125. I know you don't have room to write this, but you can do it off to the side. Minus, so, or a plus a half of 10 is 5, so, or negative 5, times 2 squared. So 2 squared is 4. So 5 times 4 is 20, negative 20, so 125 minus 20 is 105. So we're at position 105 after 2 seconds. If I do it for 3 seconds, you can take my word on it. I would just put a 3 into here, do the exact same thing I've done before. 3 squared is 9, 9 times 10 is 90, half of 90 is 45, it's negative, so it's 125 minus 45 gives me 80. Okay, after 4 seconds, 4 squared is 16, 16 times 10 is 160, times a half is 80, make it a negative, negative 80, 125 minus 80 is 45. I hope you understand where that negative is coming from because of the negative 9.8. And then after 5 seconds, 5 squared is 25, times 10 is 250, half of 250 is 125, make it negative, 125 minus 125 is 0. In other words, we hit the ground exactly at 5 seconds. So now I'm going to plot these points. I've already plotted the first point. So I'm going to go over to 20, and I'm going to go to a height of 105. So here's 100, here's 105, right there. Then after 3 seconds, I'm at 30, and I'm going to be at position 80, so right there. 4 seconds, I'm going to be at 40, and I'm going to go down to 45. And then after 5 seconds, I've hit the ground. And if I connect those, you see I get a very important shape. That's a parabola. So anytime you fire something horizontally from some height, you must get a parabolic trajectory. You must. And that's really the consequence of one motion direction being constant and the other direction being accelerated. Okay, so let me sum up that there. Notice that the trajectory is parabolic. This will always be the case when motion is constant in one direction and accelerating in the other. Now, I could ask you, what if we fired this cannon faster? Let's say we fired it twice as fast. And I wanted to sketch it. I'm not going to do all the calculations, but we can kind of infer what's going to happen. If we fired it twice as fast, after 1 second, it would be right here and then fall in the same distance, right? Firing it faster does not make it fall faster, so the distance it falls after 1 second is going to be the same. It's just going to go further forward during that same second. So my first data point would be here, then my second data point, whoops, I take that back. See, I made a mistake. I had to drop the same amount as before. So let me recalibrate. It's going to fall just from here to here, but it's going to be right there. So in other words, my next data point after 1 second is going to be right there. After 2 seconds, it will have fallen to right here, but it's gone this far. So I'm just going to go over like this. And the point is, I'm going to get a parabola that is not quite as steep. And if I fire it slower, then it's just going to be something like that. Okay? So conceptually, we can work out that the faster we fire it, the further it's going to go, but it will never, ever be flat. You'll never get a flat line, then have it start fall. So if I fire that super fast, it immediately starts falling. Okay. So the key, though, to figuring this out is the VTAD part. So let's go to the back. I'm going to have you do these practice problems. The answers are right there. Okay? The key to doing this is simply splitting up this and this. So I have an arrow leaves the bow at a speed like this, and its initial height is this. I just got to make sure I'm careful to distinguish between horizontal information and vertical information. So I'll fill out the table, and then I'll let you do the problems yourself. And then the next one, number 2 and 3, you work it out. So speed of 45, the level. Level means it's fired horizontally. So that initial speed in X direction is 45. Since it was level, that means the initial Y speed was 0. It wasn't moving up or down initially. The time we don't know. So we're not, unlike the previous problem, you have to figure out how much time it's in the air. What do I know about acceleration? It's always going to be the same thing in these problems. Acceleration horizontally is 0, and in the vertical direction is -9.8. In terms of distance, we don't know how far away it's going to land. In fact, we're asking that right here. But we do know how much it fell. It fell -1.5 meters. And it's a negative there because it's below where it started. If you don't put the negative in there, it's not a big deal. So what you can see is I only have 2 pieces of information for the X. So I can't do anything right away. But I can figure out the amount of time it takes to fall because I know 3 pieces of information for the vertical. So once I find the time in the air, I can use the time it takes to fall. So let's say this, it's not the answer, but let's say it falls in the air for 2 seconds. Then I know it was moving forward for 2 seconds. So these two are going to be the same numbers when it's a full flight. And that's why I use the vertical to find the time. And then you use that time in the horizontal to get the range. Okay, so I'm confident you can be successful with the rest of these practice problems. If you don't get the right answer right away, go back and see if you forgot a negative somewhere or if you didn't have the acceleration of the right value, but it's really much the same thing, more or less, for each problem. Good luck.